I'm delighted to have Brad Genereaux with us today. Brad works for NVIDIA. He is the Medical Imaging Alliance Manager, and he has a long history working with DICOM and IHE, which of course is the bread and butter for us in enterprise imaging. And Brad, I'll let you introduce yourself and just talk a little about your background.
Sure, yeah, it's such a pleasure to be here. Brad Genereaux, Medical Imaging Alliance Manager. What I cover is anything in the medical imaging ecosystem, whether it's on visualization, AI, virtualization, or analytics in the medical imaging and smart hospital space. I've spent about 20 years now in healthcare IT, with 10 years in Canadian hospitals, both big and small, building out things like the EMRs and the RIS and the PACS, and onto big projects like regional PACS and regional VNAs. And I also spent 10 years working with PACS and building up PACS solutions. I've also spent a great deal of time in the interoperability space, having been co-chair of DICOM Working Group 27 on web technologies, Working Group 20 on the integration of imaging and information systems, as well as chairing the HL7 Imaging Integration Working Group. I'm currently the industry co-chair of the DICOM Standards Committee.
Yeah, that's great. And thanks for sitting on all those committees. I think, something we need all these standards, right, in our industry. So they're really important. We can't, none of this would happen without all these standards, right? Like DICOM and HL7 and so forth. And one of the things I wanted to talk to you about today is, we've all been hearing a lot about AI and machine learning. It's been really the talk of enterprise imaging and medical imaging and radiology for a number of years now. But I think a lot of us have struggled to find anything practical with AI and machine learning until recently. And now we're starting to finally see some more practical applications with AI and machine learning. And now we're reaching this point where we have to start supporting it, right? And I read your IHE white paper, and I was hoping you could talk a little about that and what IHE is working on to help us support machine learning and AI and some practical solutions around that, right? So I'll let you kind of start by kind of summarizing that a little bit.
Absolutely. It is such an exciting time, right? With the advent of AI, we're at the kind of the next big thing in medical imaging and enterprise imaging as a whole. If you've followed where deep learning has started to come into the medical imaging space, it started out, we create models, we take a large data set, we train a model, we do something really interesting, and then we're able to connect it up into our imaging ecosystem and run inference and do a lot of research and things like this. But as these things start to crystallize and get commercialized, therein lies a lot of the problems when we want to scale up and scale out. So if you think about the ways that we could do this in our existing tooling, I would do a DICOM C-move from my system to an AI system or to a router in between. It's going to do some magic, create some additional objects, and then send them back to me. And that's great for, one AI model or 3 AI models, but we are on the cusp of going to thousands of algorithms per imaging study. What's going to end up happening is, for every routine study that goes through, we're going to have an AI model that will check for, 300 diseases. Why not? If you visit the gamuts.net website, it's one of my favorite things to reference. Just that alone, Gamuts indexes about 12,000 things that we can find in medical imaging. So it lists the causes and the conditions. And if we were to have one AI model for each of those things, that is 12,000 models right there. What we've seen is that we actually are doing 2 or 3 different models. Like in the COVID-19 model that NVIDIA put out mid last year, there is 2 steps. One is to segment out the lungs. And then step 2 is to, from that segmentation, actually look for, is it COVID-19 positive or not? And that's just at the medical imaging level. After we went through the process of the IHE white paper, I'd say, anywhere 75,000, 100,000 models and algorithms. And I was told this morning that that's a conservative estimate.
Yeah, that's a lot. And I think what that white paper tries to deal with, or what you're trying to wrangle here, is how do we have a scalable AI infrastructure, right? I think of it as an infrastructure to support all these algorithms. I hate to use the term AI and machine learning. I mean, it's kind of algorithms, right? It doesn't necessarily have to be labeled as AI or machine learning, but just some kind of algorithm that post processes this data. But one of the things I thought was interesting too is when you were talking about CMove data and get something back, we're thinking about, and I think a lot of us, when we think about AI, we just think of the radiologist being assisted by AI. That's kind of been all the rage, but your white paper talks about all these other use cases, right? All the way from the modality device itself, right? And even before you do the exam, there's AI that can happen long before the patient even hits the table. Scheduling and things like that, and analytics prior to the patient getting there. So there's all this, and you kind of get a sense of why this interoperability is so important. So
Absolutely.
I'll let you comment on some of that.
Absolutely. I mean, when we start to look at, when we talk about AI, and when we talked about AI like 3 or 4 years ago, even till today, we could be talking right past one another, right? And without putting a box and say, this is what this particular piece is doing, it's very difficult for us to even agree upon what we're trying to set out to do, let alone try to build enterprise infrastructure on this. And so what we did in the white paper is really started to define what is an AI application? That's the term that we landed on that draws the box around the solution that we're putting out there for every single building block. Because within an AI solution, we're going to find AI models. But it's not just the model that we care about as part of this entire process. We actually also care about the transforms that are going in and the transforms that were used on the data going out, so that we can take in DICOM or take in HL7, convert it to something that the model can use to create inference. And then on the flip side, take that output, which could be a set of binary flags, or it could be a set of probabilities, but then convert that back into what the healthcare ecosystem could actually leverage. And then even around those things, we also need our interoperability layer to talk to APACs, or talk to an HL7 engine or an EMR, or talk to an orchestrator in order for us to bring this up to scale. And actually, what are those components and building blocks look like? We really just wanted to lay it out there and say, if we were to think about every moving part in the system, what would that actually look like?
Yeah. So, yeah, and it starts to get a little bit more practical when you start to really break down all these different things. I think one of the challenges for a lot of folks has been AI and machine learning has been so amorphous, right? Because it can mean anything, and people use the term very generically. But now that when us that work in enterprise imaging, that we're thinking about how we're going to support this, it helps to break it down into these discrete elements, right? And I think that's that the white paper does a great job of breaking this down into these discrete elements so that we can digest it, right? And kind of start thinking about how to support that. One of the things that I was thinking about too is, and this has always been the challenge in healthcare, right? Is that you have these larger vendors that will sort of build these solutions from end to end within their own products, and it's difficult to implement modularly these types of things, right? We saw that, in healthcare and medical imaging, we've seen this for decades, right? Where it's there was this whole concept of deconstructed packs, right? For a long time. And everybody thought it was a great idea, and it was slow to move there, right? We still have a lot of folks that really aren't embracing deconstructed packs, but a lot do, right? And I almost look at AI and machine learning workflows kind of in the same way, where I think a lot of folks are kind of developing these end-to-end workflows. For example, modality vendors that are kind of supporting this on their device, but you can't leverage those algorithms on somebody else's device, all the way to the radiologist where it's, okay, well, I'm using PAX X, but I can't use tools that are available in PAX Y. It's a different algorithm or it's licensed. And what I'm hoping is that the vision of this IHE profiles that are being developed is to try to make sure that doesn't happen, that we have interoperability to leverage these algorithms regardless of which PAX you have, which device you have, which wrist you have, right? What do you think about that?
I think you've explained it very succinctly. You know, if you have all the pieces together, you're going to have a much more tightly knit solution that just works for everybody. We have to have interoperability where it makes sense across the board. And if there's advantage, like opportunities to have a tighter integration into workflow to make that just that much better, awesome, fantastic. But I wouldn't want to have a completely closed ecosystem because we know that doesn't work, because we are going to have modalities from many different vendors in our hospitals. And it's because it's not that we say, okay, in 2022, I open a building, I have all brand new systems, day one, everything is new, and I have the perfect system and everything's great. We have modalities that are still in operation from 20 years ago, and we still want to do something with them. You build hospitals around some modalities. Like it's just the way that it works. And we are in a very unique position in healthcare, unlike other industries where that's just something that we have to deal with. And having IHE and then the standards underneath us really help to make that field open for everyone to work together, because ultimately we're here to help patients and help the caregivers deliver their care. So I think it's the way it is.
Yeah, you know, it sounds like hyperbole, you know, to say, do I live or die? But there's a lot of truth to that, right? I mean, it's interesting, you know, as we learn more about some of these algorithms that are being developed. You know, stroke is a great example, right? And I think stroke is probably the low-hanging fruit, right? I think a lot of folks are developing stroke protocols and AI for stroke. But, you know, we're also seeing it in a lot of more mundane ways but could have a tremendous impact. You know, one example I can think of is, you know, dermatology, AI for looking at photographs and determining whether or not you might have cancer, right? It's not going to kill me today, but it could kill you in 2 years, right? And you could say, well, gosh, if they only caught that, right? So you may not die from that brain bleed right now, but, you know, other pathologies, right, that could be caught early can make the difference between life and death, right? A lot of different ways this stuff is getting used, I think. I guess my next question is, what is the next step, right? You wrote this white paper. You know, where does it go from here? What's going to happen after this?
That's a great question. So what precipitated the paper, I think it's very relevant to this. So as I said, in 2019, we had come up with 2 AI profiles, right? So 2 profiles that can be tested, can be validated, connected.
Fully baked profiles, right?
Exactly, absolutely. And then we sat back and said, what next? What's next for AI? And in the community, I mean, there's so many things that we could do. What about creating data sets, annotated data sets that we could use for training? What about the training itself? What about collecting feedback on things that are now running out there for inference? How do we collect that and feed that back to the model developers or to agencies that are monitoring safety and efficacy? So there's so many things that are out there that knowing where to start was going to be problematic. And what we didn't want to do is take one bite and spend so much time trying to figure that piece out. And then when we go to do the next thing, it's like back to square one. And hey, did we get these pieces wrong? Or we didn't think about these things. And so that's what we said, let's do this white paper.
It's
and
like a
lay it
scaffolding,
all out,
right?
All out on the table and say, these are all the things that we could possibly think about from an ecosystem. So what's going to happen next is, so IHE on a yearly basis, so it'll happen in the call for new profile proposals will happen every July, and people will submit proposals, and then they're discussed in August. They're voted at the end of September for the new work year. So what should happen is that people will use the white paper and say, well, this seems like a really good next step. Let's take this on. and we'll do a proposal supported by the white paper so that all the things, all the unknowns, all the question marks are there because we laid all those things out. So then when they actually go to write those profiles, it'll become much more efficient. In terms of what profile will be first, it completely depends on the community.
Oh, yeah.
What seems like low hanging fruit for me is really two pieces. One is on that model feedback. So being able to, I say I agree or I disagree. Also, not only is it humans agreeing and disagreeing, but also can we build out automated systems to try to help, monitor the performance of models over time. So
Yep.
that's one piece. And the other piece that I think feels like low hanging fruit would be extensions to VNAs on how to make them into data repositories that can
Yeah.
service the needs of AI. Because it feels like so there's two. I mean, we define repositories, which is like here are 5 million studies,
Yeah.
and it might have 1 million pancreas studies and 1 million kidney studies, and then you can from there derive data sets.
Yeah.
And I think that piece of what we would expect at the repository level and can help evolve VNAs to help support the needs of creating more AI, I think
Yeah.
would be a really good next step.
You're actually that was actually my next line of questioning, right? Is the VNA is this collection, enterprise imaging in general is just this huge collection of data. And the interest that we're seeing as a vendor in the VNA space is customers coming to us and saying, hey, I've got all this data sitting in my VNA that we want to use for research. How do we do that? And they're coming to us and saying, how can we use this data? And we're coming back and saying, well, how do you want to use it, right?
Yeah.
And there's really no clear definition of what that would look like, what you need to support in the VNA. Things like de-identification of the data before it goes to researchers. Does that even need to happen? And if it does, what do you de-identify? And what approach do you take to that? How do you re-identify it if you have to? There's all kinds of concerns that come up. And to your point, how to curate that data, right? And that's been an interesting topic for me is how do we design a VNA in such a way that we can unlock all of this rich data that's sitting in the VNA.
It's not enough, I'd say, on like how do I discover, for example, like give me all these studies that has a series that has a body part of this and does not have contrast. Like being able to query that out,
Right. Yeah.
at high
That's a
value.
normal use
I mean
case.
that absolutely like on top of like give me all these studies for patient 1, 2, 3, which is what a VNA typically would be responding to. It's that big data piece, right? But it goes beyond that on, a great example that we uncovered as part of this white paper process was as we create our data sets in medical imaging AI, we need to be thinking about reproducibility. So that if I create
Yeah,
a model
reproducibility,
today
sure.
and then I create,
Yeah.
I go through the same process with the same data a month later, I should get the same model again, right? And that's not often the case, and that's a big problem for the regulatory side of things. So if we are creating collections of data in a VNA, we need to version that. We need to say this is what was in that repository at such and such a time, so that if I were to come back a month later and try to recreate my model for testing purposes or whatever, it can do that. It could say, well, you did this run and you had these 10,000 studies. I will give those back to you. So it's slightly because you can't say, well, here is now you have 12,000 instead of 10,000. Where do these other 2,000 come from? What are the impacts on creating models? You still need to use them, but if you're coming at it from a reproducibility perspective, you can't really have that. So there's tweaks on features that need to be kind of part of that process, kind of rolling forward, and that's some of the things that we were able to uncover.
Brad, thanks for your time today. Appreciate all your insight on your IHE white paper on AI and machine learning and where we're going to be going with workflows in AI and machine learning and how we can support that enterprise imaging.
But it's a pleasure. Thank you so much.